Okay, now here's hoping my computer doesn't explode. Uh, well, for now, yeah. This is going to be my PC nuke. Yeah, I think my problem is that I don't know how much compilation is going to take. So things might go a bit awry. I don't know. I don't have any way of like getting this image into another computer and then just doing it from there. So we're just gonna have to see if my computer just slows down to a crawl. Anyway, hello. So a while ago, for a really like dumb thing I was making, I needed to make a unit converter tool. A unit converter thing to go in my code. My dumbass thought, hey, what if we made it so that everything is defined on a type level? So you essentially get your big decimals, you tag the big decimals with a unit, and then have it, and then use the type level information carried in the generic types to determine the conversion that needs to be made. And then we also made the system smart enough so if it's got a conversion from A to B and B to C, it should be able to automatically derive a conversion from B to C. I kind of rushed this implementation because, well, initially I only needed a very basics implementation for a thing I was making. And then I showed it somewhere, and then they were like, hey, could you try converting these, like, ridiculously complicated units? Yeah, so this is these are units that are apparently used in chemistry, something to do with, like, fluid permeability through a membrane, of which I do not, and of which I would explain, but I don't actually know how to explain in simple terms. It's just the rate at which some fluid can go through a thin layer. Or was it gas? Oh no, it's gas because it's pressure. It's not even... I mean, gases are fluids, so yeah. So it's fluid permeability through a membrane. So the units are extremely cursed. It was something like centimeters cubed at standard temperature and pressure multiplied by centimeter over centimeter squared times centimeters of mercury per times second, and the conversion was to moles to mole meters over meter squared times Pascal times second. It's cursed, I guess. And what I want to do is I want to make this system a bit better because I kind of had to rush some of the implementations just to get something that worked to complete the thing that I was challenged with. So now I'm trying to make a better version of this that's a lot cleaner and easier to use. I was told that this is a thing that exists in as a library in Scala, but it's like really old and barely maintained. And I don't even remember the name of it because I don't remember anymore. Actually, let me see if I can find it. Scala type level, Scala unit conversion library. Squants, that's what it was. It was, yeah, this is an extremely old library. I do not know if it's actually maintained anymore. But it essentially uses some funny type level information and stuff in order to prevent you from converting or adding things that shouldn't be added together or something like that. I don't need unit addition, I just need unit conversion. So here we are, doing unit conversion. So the first thing we need is to make all the boilerplate, which I've thankfully already, which some of the boilerplate my past self has already made for me. So what this is a system to be able to give a type extra information that only lives at the type level. A tag, if you will. You can still use the same... You can still use a tagged type in the place where the untagged type is used. It's just that that type will just have a little bit of extra information at compile time only, not runtime, that says, hey, I'm this little tiny tag that's attached at compile time that disappears at runtime. It kind of abuses the way typecasting and type intersections work in Scala, but it works. I'm not complaining. So I'm just gonna borrow this real quick from my past self. Yeah, that's cool. And now the other piece of typing boilerplate that we need is this. This is a simple way, because Scala has a way to check at compile time, to ask the compiler to ask for a proof that two types are the same. This is not very useful with concrete types, like for example, something, if I summon a proof of int is equal to int, yeah, that's not very helpful, is it? But if we can prove that, for example, a generic type is an int, that's a lot more helpful, right? Or if we can prove two generic types are equal, then we can do some typecasting in between them safely without any weird things happening. But you can also use them for... Oh, welcome back. But we can also use the type equality in, like, machinery that manipulates types at compile time, so that we can say, hey, if these two types are equal, then we can actually proceed with this calculation, for example. This is essentially the opposite. We are asking for a proof that are these two types not the same? So, you know, if I try and summon an instance of int does not equal float, this works, right? But then if I do an int is not equals to an int, it won't let me. And the way this works is we define an instance. Well, we say for every pair of types, we want to define it. I have no idea what's happening. This is too much for me. Should I start again from the very beginning? But the summary is that I'm trying to make an improved version of a unit converter that I made a while ago, where instead of providing units as like strings or something, we're basically just encoding the units directly inside the type system as generic type parameters, and just having the compiler do it. Well, the only thing we need if we want to define a conversion from kex to kecw's is to define a constant that converts between them. Let's do that later. But essentially, I currently right now need the boilerplate from my past self, because this is like this one on the right is like a really bad version that I made a while ago. I'm gonna make a better version because the one I made before was kind of meh. So here, yeah. So this is now a simple piece of machinery, a simple way that we can check if two types are in fact the same type or not. I don't even know if you need both of these cases, but I keep both of them here, because the way this works is we're abusing the way that the Scala's implicit handler works. So implicit values are values that the compiler can determine from given a set of starting values, right, that are marked as implicit. So in this case, in order to make this work, we basically say every pair of types that you can ever put in are not equal. But then we also put in a case such that if the compiler finds them as equal, also make another instance of it. This confuses the compiler, so it stops searching that path, saying, hey, I found multiple paths to go from here. I'm not going to expand here further. This tricks the compiler into allowing us to actually check if two types are not equal. It's really hacky, but it works. I'm not complaining. In fact, I don't even think you need two ambiguous cases. I can probably just get away with one. Let's check. Yeah, it actually works. I don't even need two ambiguous cases. I just need one. I'm actually going to rename this as well, because I want to follow the convention. So I think the convention that the scholar uses is equals, exclamation mark, colon. Ugh, that doesn't look that good. No. Yeah, sure, that works, I guess. Yeah, we'll use that. Maybe that? Nah, this one's better. That's better, I think. Although these now are look very close to each other, it'll be fine. So, I think now I want to make a better version, because in the previous version, there isn't a way of putting, for example, centimeters cubed. It wasn't very clean to try and make. You had to manually multiply them together like this, and if you want to make, like, I don't know, centimeters to the power of 4 for one reason or another, it'll just get pretty awkward very quickly. So I want to make a way of making, like, units, like exponentiated units. So I think what we're going to need are some numbers. But we don't have any numbers. We're in the type system. We haven't even reached the program yet. We're still in the compile time step. So how do we make numbers? Well, the old-fashioned way. Well, we make numbers the old-fashioned way, obviously. Let's use base 4. Let's use base 4. Because I don't remember which one is actually the most efficient. I think binary is... unary numbers are very slow. Binary, I think... there was some compromises between speed and complexity that I don't remember. But I should be able to just define numbers starting from here. Let's see. Sealed class. And now what we need is, let's see, sealed. Alright, let me see. I have to remember how to do this. It is 1 num 4 2 3. Oh no, we actually do need a 0 as well. Oh, that's annoying. We need a 0 as well, right? Yes, we do. So now let's time for the boring part, which is to write a bunch of numbers. Okay. So we have 0 here. Now let's make a bunch of other ones. Number 1. That is a 1. 0. Extends non-zero. Now, it might be weird that I'm putting this as non-zero, but this is only ever going to be used as like a placeholder, you know, like how you have 0 in the 0 in 10 is not actually is making it so that the 1 actually means a 10. Yeah, so this is the real 0, and this is the... How do I explain this? This is the real 0, and this is just the decimal placeholder. I guess a quaternary placeholder in this case, because I'm doing base 4. Sure. I'll use QNAT as well. And I think we'll also go, and in order to make things a lot easier, I think we may also want negatives. Right, how do I do negatives? I think the best way to do negatives would just make a sealed class non-negative, and we want a number that is non-zero. Why did my cursor jump to that side of the screen? Get out of the way. Alright, oops. Yeah, sure, this works. This is Scala, but I'm essentially abusing the hell out of the language. Normal Scala does not look like this. Normal Scala actually looks sensible. We are delving into the realms of type-level programming, aka we are making the compiler do all the work for us. Screw the runtime. Who needs runtime? We're gonna make the compiler do all the work. Yeah, basically. We're making the compiler do everything. Who needs, who needs... Who needs a goose? No, we're going a lot more primordial than that. I am a black hole formed after a collapsing star. Oops. No, you just need to, yeah, there we go. Oh, and I also forgot. Now we need to make a bunch of these. Well, this is great. Give me a minute. I think it would be a good idea if do we want to be able to do this? Yeah, sure. Yeah. Let's just make these case classes. And why did I make this a sealed class? We want to make this a sealed object. Case object, sure. So now we can make some values. Let's make them lazily computed so we don't actually explode the compiler. Q1. This is the boring part, defining some numbers. Is 1 Q0. Oh boy. Wait. What? Sorry, I thought something... Hang on. I need to remember, do we actually need the values? Actually, we don't even need the objects themselves. Now that I think about it, we don't even need any actual objects. We don't need no stinking objects. We can just make types. Yeah, there we go. Oops. This is going to take a while. That's okay. We got 1, 0. Wait, hang on. Am I doing this right? Yes, I am doing this right. Because I am just realized. Okay, hang on. Give me a second. I need to remember, what did my numeric system look like? Because I remember doing this before in another language, and I need to look it up. No. No. This? No, that's actual numbers. This? No. Is it called, did I call it NAT? QNAT, I did, yeah. What did I use? Oh no, I didn't. I did actually have a Q0. Where is Q0 defined? Where did I define Q0? Wait a minute. Where did I put it? Oh, there it is. It's all the way down there. Why is it down there? I am actually doing this correctly. I am actually doing this correctly. Oh boy, this is going to be painful to generate. Oh no, the compiler is definitely going to be fine with this. I've abused it way too much before. How much did I define it up to? Oh, that's how much I defined it up to last time I tried something like this. Well, in that case, let me do some shenanigans then. F6. Or... So you can probably see that this is going to take absolutely forever. So what I'm going to do is write a script to generate all of these lines for me that I can just paste in. Because I can't be bothered to write all of these numbers all the way until 1024. So I am going to go make a script to generate all of those. Where is it? Scala worksheet. Thank you. Move you over to this side. Put you over here. Okay, so I now have to make a case object Q0. In fact, I don't even need a case object anymore. I can just make this a class and just make it final. DFE. E. Okay, this will take a second. Alright, bye then. QNum extends QNum. I need these as well. Nope, I don't need any of those conversions. QNum. I just mean it's a QNat. Nat. I don't need these extends. Oops. And now I should be able to do, I am going to make a sealed case, some case classes. And I put in a n num n num n num n num. Now my question is, did I do these from outside in, or did I did these inside out? It looks like I did these outside in. So Q4 is actually 0 of 1 of Q0. Yeah, so I'm basically writing the digits backwards. Right, which makes things way easier because then I can just do this. So I increment this. I just have to do n match to exhaust this. Yeah, Q0 becomes 1, 0. It becomes a 1. And don't type. What? I'm a little bit dumb. I've already lost my ability to do this. Yeah, okay, sure. Oops, I'm a bit dumb. I just want a 1. Ugh. Yeah, I need a 0. Hang on, how does this work again? My brain hurts already. Hang on. If I increment that, I need to make a 0 of increment n. I'm just gonna, yeah, just have it intelligently figure it out. My brain is not gonna work. All right, cool. Now I should now. Wait, my brain's not. So now that I've done this, I should be able to. Is there an iterate, like, or like a repeat application of a function? Is that a thing you can do? Is there an unfold? Yeah, there is in fact an unfold. Never mind, there isn't an unfold in Scala. It's just I have to define... Or not? When did this get added? That's a thing? Is it a case class? No. New unfold. Sure. So you want to unfold, and the function is going to be is there a take? This one's going to be infinite, so is there a take? There is, in fact, a take. I hope that this doesn't cause the thing to explode. Uh... Oh, right, there's another one. I also need to make this a sum. No? Am I dumb? Oh, whoops. I just need the first 1025 to make string separated by new lines dot replace. I need to replace this with this, and then I also need the one for the other one. This should... No? Oh, hang on. This is annoying. Right. I need to define a way to make this... Oh wait, I can just do the thing. Or I do dot zip with index dot map case x n. No, that's the... Whoops, I need n x x. There we go. Qx equals n. There we go. This should give us what we need. I am going to make it plain, so it actually doesn't... So it prints out in a window instead of... Or not. I guess it's still going to do this anyway. What is Q0? 1, 2, 3. Output exceeds cutoff. Right. Well, we're gonna have to do this the other way. I guess instead of printing the entire thing, I could just, Does that work? That doesn't look right. Right, because I did make string, didn't I? Fun. How do I print this then? Output exceeds cutoff limit. How do I run this? Well, I mean, there is one way I can do this. Just copy this. Move it over to the main class, which I haven't deleted. Move it over to here. Yep, that should do it. So now I should be able to just print this. Hopefully? Perfect. Now I can copy this output. I don't think I'm gonna need any more than 1024, but you know, you never know. Maybe you might need more. There we go. Now we have 0 through to 1024. Holy crap. Would it be a smart idea instead to... Um... that's annoying because I don't know if I can define that, because if I define that, it may just cause... Oh wait, no, I said I didn't even need the numbers themselves, right? Would it be good to actually define the numbers? That's the real question. Is it a good idea to be able to turn these from values to is it a good idea to turn these into values as well? Hmm. Uh... Is it a good idea to also define object versions of this? You know what? I think the answer is yes. So let's do that. You know what? I think it might actually be good to do that. Hmm. Except how am I supposed to actually define their types such that, for example, 0, 1 actually works? Hmm. Maybe it just works. Let's see. How did I convert these into real numbers in my other library? All right, let's see. I don't think we need anything larger than int. Because other than that, it's just, uh, yeah, sure. Hey, wait a minute. This isn't going to work, is it? Hey, wait a minute. This isn't going to work, is it? Wait, no, it will, because the minimum is 0, 1. Maybe it might? Hmm. Maybe. So what if we have, for example, 1, 1, right? Like this. I have a feeling this might not actually be correct, now that I think about it. Because, for example, 3, 2... Hmm. Yeah, I don't think this is actually correct, now that I look at it. I think the way I've defined it does not actually work. Hmm. Hmm. Because if I have 1, 0, 1, right? Yeah, no, this becomes 8. No, this becomes only 5, which is not correct. Yeah, so this old code that I wrote actually is completely wrong. Uh, that's annoying. Hmm. Maybe it's not a good idea, actually. Yeah, I think we'll just keep these as compile time values. Yeah, we'll just, you may keep these as compile time values and just do some funny shenanigans to get their values later. We don't need anything dumb. Do we? Hmm. Well, at the very least, we need a way to increment and decrement the numbers at least. So we'll write some machinery as well to do that. So let's make machinery. Uh, Hmm. Oops. Uh. I may have to make this abstract. Yeah. Now to make the cases, which would be an expanded version of these cases that I've written a long while ago. Bother. Let's see. Hmm. Uh, let's worry about the negative cases later. Let's just do the positive case. Uh, Yeah, that looks right. 2, 1, and then this becomes 0, and this becomes 1. Oh boy, what's it complaining about? Right, yeah, that's annoying. I have to actually give them uh thing. Is there a way to auto-infer? Uh, no, auto-infer type parameters in constructor. No, why am I getting PHP results? Why the actual hell am I getting PHP results? Okay, looks like I can't actually use abstract class. I have to use a different thing. That still doesn't work? Fine. Fine. You win this time. Oh, really? Can I add cursors? Yes, I can. Now, it'd be good if I actually press the correct button, and I think I've just caused my editor to just crash. Oh, or not. No, it's still going. Ooh, it's chugging. It's chugging. Come on. You can do it. Ooh, this is very, very slow. Ooh, I've just realized something. I will have to make the negative increments elsewhere. Well, this is kind of messed up. This is a little bit messed up. Ooh, that's kind of messed up. I have to make the negative machinery elsewhere, because otherwise we'll get ambiguous um, things, and it's just not going to work. Ooh. Right. 1 minute. Oh boy. Yeah, give me a second. Oh, hell yeah, everything is just real slow. This is wonderful. Oh boy, the computer is starting to redline. This is not good. Alright. I'll just move a couple of things then. Um how am I gonna do this actually? So what I need are two different traits. Yeah, okay. Don't worry. This is going... Oh! Shut up! Oh, dang it. You serious? Did not mean to knock that over. Right. So what I need... Oh, no. So we need to move all this up here. Oh, dear God, this is getting cursed. Well, this is getting cursed. And then we need to put these in here. Now we need to move these in here. Oh god, this is very cursed. I already have to deal with implicit oh, what's it called again? Implicit priority. So all of my imports are going to be off of the numerics object. Then it'll find any implicits. It'll try to find anything here, and if it doesn't find anything, it'll delegate that to the class above, which is arithmetic, and if it can't find anything there, it'll delegate it to the class above, where it now finds negative arithmetic, and then numbers. This is way more cursed than I'd hope. Oh god. Do I actually need that? Yeah, I do actually need it, because otherwise I wouldn't be able to encode the pause on the zero case. The border case. Edge case? Boundary case? Sure. Actually, you can't even have -0. That's not something we want. We don't want -0. -0 is weird. And not in a good... -0 is strange and not in any good way. So we don't actually want -0. There are so many cursed things being said on this stream already. There are already so many things being said here that are extremely cursed. Now I need the boundary cases. Uh, thought I was going to make a bit more progress, but I wasn't expecting to get stumped by numbers of all things. Right, Hmm. Hmm. That's terrible. So now my question is, oh God, oh no, oh no, oh no, um, oh no, oh bother, oh no, oh no, no, this is so bad. Yeah, I'll just assume this works. Oh boy, everything is chugging. Let's just put it that way. I don't think we need addition. I think this is good enough. I hope. Let me just quickly test something. Oh my God, it actually worked. I was not expecting this to actually work the first try. Um, this is still painful. Oh my God, this is ridiculous to look at. Oh no. Oh god, what have I done? Why did I make base 4 numerics? Type level base 4 numerics? This is just... This is pain. Alright, now that that's over, now we can actually do some of the machinery that I probably should have gotten to in, like, absolutely forever. So the first thing we want is is units. How do we actually define units? That's the real question. Let's actually make a file for that so we don't clog up machinery with random stuff. So how do we make... I mean, I guess units can be quite literally any type, so they don't have to be anything. So the thing that I want to do now is to define a way to multiply units and sort of exponentiate them. Because, let's face it, you don't want to write centimeters cubed as centimeter times centimeter times centimeter. So we're going to need a way to compose, I guess, multiply and divide units. Well, I guess we don't need to divide units since we have negative exponents. And if we have negative exponents, we don't need division. We don't need type level division. That's definitely one of the statements that I've had to say of all time. We do not need type level unit division. Like in my old system. So what we need is an exponentiated unit. Or I guess we just need to make a trait called unit. How about we make it so that we can only multiply... So that we can only ever multiply exponentiated unit. No, but then you'll have to do something dumb, like then you'll have to do something dumb, like say, oh yeah, centimeters to the power of 1, and who on earth wants to do that? So let's not do that, and just make a unit trait, and another, I guess, class, where we can say to the power of. Yeah, sure. We're gonna need our numbers, so let's import conversions.numerics. This. So we need... This is cursed. I apologize. If you have centimeters cubed, does that... Wait, if you have centimeters cubed, do you get centimeters to the power of 9? Oh god. Oh no, why? If I do this, if I make the units recursive, I will have to be able to simplify them. FML. I guess I want... Oh my god. Please? 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 Oh my god, this is chugging so hard. This is not good. There we go. So we want qnum with non-zero. There we go. That should make... Uh, uh, this is not good. Well, I think non-zero is actually redundant. No, non-zero is not redundant. What is redundant is qnat. We don't need qnat. You can instead be a qnum. And you can get rid of this. And that has to be num. No. We want qpause here. Maybe it's not actually redundant. Give me a minute. Give me a minute. Right. How much does this break? Ouch. Yeah, let's just make this qnat. Let's just do that. Just so then we don't break anything. It's fine. So now we have... God damn it. Now we have unit exponentiation. Now we need to make unit simplification. Oh, God. Welp. The question is... do we simplify units? Do we need to simplify units? Do we really have to simplify units? Is that a thing that we have to do? Can you have a unit that is literally... oh my god. I have a better idea. What if, instead, we do not want anything... what if it... right, sorry, 1 second. Sorry about that, things just started falling off. I now have to figure out how do I deal with unit... how would I deal with unit exponentiation? um... Um... How do I do this? God, this is cursed as fuck. I can't make type aliases that are a single underscore. Can it be two underscores? Yes, it can, but it cannot be a single underscore because that's a wild card. Can I make it this? Can I make it an at? Two ats. Three ats. No? Okay, fine. A pipe. Surely there's a better way of doing this. I wish there was somebody here to ask. Would there be a situation where you would ever write a unit? Like, would you ever, for example, in some situation where let's say you have oh my god, say you have some unit U. Is there any situation where you ever would write something along, oh my god, something along the lines of U squared to the cube, or something like that, like U squared cubed? Will there ever be a situation where you do that? There's gotta be some like super esoteric unit where that makes you do that. Surely. Surely. Centimeter squared cube. Surely that's a thing. For example. Um I'm gonna ask in a bunch of places actually, because I don't know and I don't want to do something dumb. Oh, wait, hang on a minute. Ooh. Right, hang on, sorry. Give me a moment. I'm gonna have to figure out how to do this. Oh wait, what am I doing? I can just, instead of doing it here. Sorry, one moment. Yeah, I could just use this instead. Okay, now my biggest question is still a thing. Will there ever be a situation where I would have to write something as screwed up as unit squared cubed? Is there ever a situation where I have to write that? Come on. There we go. Nope, that's not. Nope, that's too steep. That's better. Sorry, I just had to quickly set something up. I should now be back. I need to ask a couple of questions in a couple of places just to make sure that I am not going insane. Because I think I may possibly be going insane, and um that's not very fun. I'm gonna see if there's anybody. There's anybody here that can answer. Uh is there ever any situation where one would ever write something like centimeters squared cubed? Like, is there ever any situation where that is a thing that you are forced to do? Hopefully, I don't think the answer is yes. I'll work on the assumption that the answer is no. In which case, I may be able to make things a little more streamlined. Can I use this? No, I can't because that's used in path dependent types. Can I use a tilde? Yeah, but that feels kind of wrong. Can I use a... That also feels wrong. Can I use a backslash? I can use a backslash. That is a little cursed, but you know what? I... Can I use a... Can I use a comma? Can I use a dot? 2 dots. 3 dots. No. Can I use a no. Can I use a colon? Can I use a semicolon? Can I use... No, that makes a... Can I make a... No. I'll use the backslash for now. So that's going to represent... u to the power of q1. Yeah, there you go. Oh yeah, I also want this to be non-zero. Because the centimeters to the power of 0 is basically just unitless. There is no point. And I also want a what I also want is a multiplication. Sealed class times equal. Oh god. Oh, does this work? Well, I'll see if this works later. So, example unit for acceleration would be something like, what was it, meters times second, meters to the power over second squared. So it'd be like a meter times second squared. This is... I hate this. This is cursed. Oh, I think I should also make SI units. Should I also make SI prefixes like its own thing? Yeah, I should probably make SI prefixes their own thing. This is gonna be cursed. I think we can now finally start defining some stuff. I think we can finally start defining stuff. Here we are. Wait, no we can't, because there's another thing that we need. Oh no, because I also want to implement an optimization so that if you convert one thing, if you convert A to B, and then you convert it back to A, is this optimization even worth it? It just saves one multiplication. Is one multiplication really worth saving? Because a lot of these are probably just going to be conversion constants that are pre-computed exactly once, and then never computed ever again. Is it worth it? Something tells me the answer to that question is no. So I am not going to implement that optimization because that optimization is dumb. So let's start making the machinery. I can probably just copy this, right? I can just copy this. Yeah. That's cool. And I guess we also want these. These are the main. What? All right, I have to get the types. Import types, conversion stop types. Stop. Yeah, there you go. Yep, looks good to me. Except we have a problem. Except we've got a bit of a problem. Uh. Yeah, we have a bit of a problem here. I don't know what the hell I was doing with all of these mults. We'll figure it out later. Right, so now that we've got our basic machinery, now it's time to... Hang on a minute. Okay, now that we've got our basic machinery, let us now finally start making the rules for how to convert a unit into another unit. So let's take a look at our rules. Let's start from the bottom. Uh... Yeah, let's start from the bottom. So, great. Simple conversions. So, let's get some of the simpler ones out the way. For example, if we have uh uh let's just do a simple exponent conversion. Yeah, so this is where okay, now this is where I realize being able to convert the numerics will actually come in very handy. This is where I now realize that being able to turn our numbers in from type level numbers to real numbers would be a good thing. So, I have a question for everyone. How the hell do we do that? So I have a question for everyone here. How in the actual hell do we do that? How do we convert a outside in number? How the hell do we convert a number that is outside in into a actual integer? How do you propose that we do that? Because we are looking from the outside in, right? So we essentially have the least significant digit, and we have to work our way to the most significant digit. How do you propose we do that, actually? Right, give me a minute. Let's see if I can think this through. Oh my god, there are so many declaration is never used warnings. Oh my god, can I disable that? What is this? Project-wide analysis. Can I, like, just for this file, can I? Can I? No, I can't. I can't disable usage warnings. Can I, like... What is it? It's like a file. No. Can I do this? Really? No? Where is this defined? Scala do not see. Scala do not emit warning on unused value. Okay, fine. I'll just use no warn. No? Do I have to give all of these? Ah, that's good. Can I not do that? Am I just stuck with all of this? I guess we are. Oh, bother. Uh, yeah, it looks like we need some more arithmetic. Let's go. Hmm. Uh, how the actual hell do I do this? Uh, wait a minute. If you left shift a set of digits, if you do a left shift, for example, if you left shift 3, doesn't that just become 6? Am I stupid? I may possibly be stupid. I may. Wait, no, I still need the value of because I don't have the actual objects themselves. I think I may have just been overcomplicating it in my head. I may actually be dumb and just really overthinking it. Yeah, I am just overthinking this. Yep. This is me writing cursed stuff. I'm forcing the compiler to do work for me. Because, yeah. I am making an improved version of a unit conversion tool that I made like a month and a bit ago. And when I say unit conversion, I mean, oh god, everything is dying. When I say unit conversion, I mean I am forcing the Scala compiler to automatically derive conversions. So let's say I only have a couple of conversion constants, right? I have, I don't know, meters to centimeters, some pressure, one pressure conversion constant, and another weird particle count conversion constant. And then I say I want to convert this absolute monstrosity of a unit into this other monstrosity of a unit. I'm making the compiler automatically derive a constant to do the conversion with, and then perform it. Originally, I just wanted to, when I first made something like this, I wanted, oh, no, 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 not double to single. It's a unit conversion. So, for example, if I want to convert like centimeters to meters, hours to seconds, that kind of thing, right? So if I have, so for in the second example of if I of hours to seconds, like let's say I have a conversion from hours to minutes and minutes to seconds, but I don't directly have a conversion from hours to seconds. And the idea is I want to make the compiler automatically derive an hours to seconds conversion just from the first two, along with a bunch of other stuff. I also want to build a system that so that you can just define units directly as types without actually having to make classes for every single one of the units. So I'm basically just taking the standard big decimal and tagging them with like extra types that never appear in runtime. Those types only ever occur for the compiler to see, essentially. And then using those ghost types that are attached to some real types, I'm basically dragging around extra information that only exists in the compiler and does not, and theoretically should not put any stress on the runtime. Auto force miles to be displayed. That is technically possible. I just have to define a conversion from mile to kilometer. But then if I wanted, for example, further convert miles to centimeters, if I have a conversion from, let's say, miles to kilometers, kilometers to meters, and then meters to centimeters, then it'll be able to just automatically get from miles to centimeters by just doing a couple of hops. If that makes any sense whatsoever. And currently I am trying to define numbers. As in numbers that live outside of runtime. So I don't know if you're looking at the screen exactly, but I have defined base 4 numerics. But that's possible. But I have defined base 4 numerics that live only in the type system. None of these are ever going to be turned into actual objects. But although I do need the numbers for them because I am allowing the user to also make exponentiated units, so like centimeters squared, centimeters cubed, seconds squared. And I have a format for, here's an example for acceleration, and this just looks so cursed. This just looks really bad. But if it works, the user does not have to interact with any of the backend when all of it is done. Yeah. I think originally I had like a really simple version that I originally made for some thing I was making involving gears and RPM and a bunch of other stuff. I remember showing it somewhere in like a server, and then someone there was like, "Hey, why don't you try doing this conversion for these two units of what was it? Gas permeability through a membrane." These are real units. Centimeters cubed at standard temperature pressure multiplied by centimeters all over centimeters squared times centimeters of mercury times second to moles times meter all over meter squared times Pascal times second. Those are real units, apparently. I don't know nearly enough chemistry to be able to make sense of what on earth is happening there, but yeah, that was something that did end up working. Although I had to take a lot of shortcuts and there are a lot of rough edges in the existing implementation, so I'm currently trying to make a better version that is a lot less janky, let's just say. Well, the back end is going to be a lot more complicated, but the actual front end, where the user interacts with it, should hopefully be a lot simpler. Hopefully. So currently, this is just defining numbers in the type system so that I can do stuff like, meters times seconds squared. And then in the machinery, I'll be able to do something like a value of n, where if the compiler can find an existing conversion between some unit A to some unit B, I should be, and it knows the value, the numeric value of n, I should be able to do A to the power of n to B to the power of n. Yes. So, let's see. If I do centimeter squared to meter squared, I have to divide by 100 twice. Yes, because I have to divide by 100 twice. So that is actually correct. So now that I have that, I can do conversion conv dot val dot, how do I get the value? It's constant. I can now generate a conversion of, you're not going insane yet, don't worry. I think the insanity has already come in just from the fact that I am working purely within the type system. I think the compiler hates me now. So I think I now just do conv dot constant. Is there an x pow? What's the method called? Okay, it is pow. Value of dot value, yes. So for example, this is the conversion for, say I have cm to meters. This performs conversion, this derives conversions of e.g. cm squared to meters squared. So the interesting thing about implicit values in the language I'm using, Scala, is that the compiler will the compiler essentially, if it can find a route to the implicits that you are looking for, it will just automatically derive them and just get them. So if I define these, if I have a centimeters to meters conversion, this will automatically derive things like centimeters squared to meters squared, centimeters cubed to meters cubed. It's quite nice, actually, being able to do stuff like that automatically. There's a lot of things you can do with this if you're not making something stupid like this. You can do, make things like little miniature, like, languages inside the language for, like, special purposes. Like, a really stupid example, if I can pull it up, is, oh, hang on, let's see. Oh, hang on. Please tell me this is what it is. Oh, yes, this is what it is. So I can, with things like implicits and the way that the Scala syntax works, I can basically, if I can find where my OBS source is, what is CC? Other. Yeah, sure, that's good enough. Wait, is there any filters on this? There's a crop filter. Let me get rid of that crop. Where is Notepad++? There you are. Oh, you were on the wrong layer. Yeah, there you go. So you can see, using just implicits and a bunch of other stuff, I can essentially define something, a miniature language, inside the language. So I can write stuff like this. A car with an n-speed gearbox has this size tire, this minimum RPM, this maximum RPM, this shift point, this final drive, and then the gears. And then I can essentially make myself a car gearbox builder. And make it look like it's just I'm writing in English. And make it look like I'm writing in English. This is this is probably one of the best, the nicest parts of Scala, of being able to just do stuff like this. This is what I'm essentially doing. I'm making a language, a unit conversion embedded language. Okay. So now I need to add the other rules that I've had, which is... Does this do negative values? Wait, does POW do negative values as well? Let me check. POW, new this big decimal dot POW, or big decimal dot Java. Are we there yet? Okay. Int n. Where is n used? If n is equal to 0, return 1. If precision is 0, 1 plus I equals 31. If n greater than 0, I get 1 divided by ACK over work MC. Okay. I do round ACK MC. Okay, cool. It does actually handle negatives, which is nice for me. That handles negatives, so I don't have to worry about... Did I define negatives yet? I have to redefine simple math. This is hilarious. Yes, I did define negatives here. Vn, if I have a negative value, then... Okay, cool. I just realized this is completely wrong. Meters per second squared is that. That's meter. Oh, wait, and also I would need the backslash here. Yeah, there we go. I still can't think of a good symbol to represent something to the power of 1. Something to the power of 1. Unless I allow anything on the left-hand side. What am I doing? I don't have to do any unit simplification, right? Because if I don't have to do unit simplification, because if I have an exponentiation, if I have an exponent conversion on the left, on this side, it'll just handle itself, surely. So I don't need this. So I can just have meters per second that looks like this. It actually looks normal. This is so cursed. Yeah. So now I need to implement these two ones that I've been looking at here. Where if I have implicit def, I might actually just be able to copy and paste my old definition and just remove some stuff. Yeah, I can just remove these T2FE. And same with this one and this one. Remove this, remove this, and remove that. Yeah, okay. Put these in. Nice. So these are essentially saying if I have two units where that look like this, then I don't have to do anything dumb. Then I only have to just, to derive this conversion, it's just this, because this unit is the same, so I don't have to do anything dumb here. Cool. So this is where things get complicated. Now I have to define some transitive some transitive and some other stuff. Yes, this is where I have to start defining some more complicated conversions. Right, so we now need sealed trait. Let's just actually number these. So these have to expand outwards. So this is going to be not simple conversions. This will instead be conversion stage 1. This can be conversion stage 2, where if we can't find anything in stage 1 to resolve our problem, then we will need to consult conversion stage 2. And this is where some things Alright, we have mult conversion, so we have so we have L1, R1, L2, and R2, not to be confused with controller input buttons. Implicit. So now we are looking for, we are making L1, R1, convert that to L2 multiplied by R2. Right, and now we need to do that. Nope. No? Really? Okay, there we go. So now we need two factors. So we need lconv, which is L1 to L2. And now we need the right conversion, which is R1 into R2. This you start getting into a bit of a rhythm once you start doing it, really. Hey, wait a minute. I don't actually need this, right? What I actually need I guess it's the same exponent conversion. I guess what we also need is a different exponent conversion. Give me a second. That would be... Ooh, yes, okay. So now we need a implicit, yeah, two larger conversion. Different exponent conversion. We have UA, so we have a unit, one exponent, and another exponent. Both non-zero because having a zero exponent makes absolutely no sense for a unit whatsoever. Now what we need is the value of my brain is currently not functioning. N and VM. Where this is going to auto-derive, oh my god, conversions of u to the power of n to u to the power of n, u to the power of m. Do I? Hang on. So if I have u to the power of 1, aka u, I mean, I guess there's... Oh, wait, no, I also need to import another thing. Yeah, I need that, because otherwise it just won't let me. Huh. So if I have, for example, meters per second squared, and I want to convert it. Oh, wait, no, that doesn't even make any sense. This doesn't even make any... Like, this makes no sense. However, if I have... Yeah, no, converting meters per second to meters per second squared without another value of seconds makes zero sense whatsoever. What I need... but if I'm converting meters to minutes... No, that's already solved by same exponent conversion, so I actually don't need different exponent conversion. Get this out of here. Thank you. Okay. So we have mult conversion. That's a simple one. And another simple one is, that can probably live next to it, is transitive conversions. A, B, C, where if we have these two and we also have A and B, because we don't want any weird shenanigans when it comes to we don't want any weird shenanigans when it comes to, like, we don't want any loops in our code, because that would be a little bit bad. Yes, this should hopefully work. Wait. If I want to invert... Oh, God. I'm pretty sure there are, like, really complicated... Alright, instead of thinking about that now, we'll test some units later and figure out what goes wrong later. Let's not think about that now. You know? Let's just not think about that too deeply at the moment. It's fine. Oh no. It's fine. Just don't think about it too hard. Yeah, let's not think about this too hard. Yep, here we go. Hmm. Oh boy. Oh. Hmm. There we go. That's a little optimization, so repeated inversions don't keep building a massive tree of objects. There we go. That should make an optimization such that if I invert a conversion 50,000 times in a row, it's not going to build a massive tree of objects. Don't make any sense. Okay, I think... Okay, I think I have something. Let's try it out. This is a horrible idea. So we have a main class here that I can just borrow. So we defined everything inside machinery. So let's get the joke out of the way first. Let's get the joke out of the way first. Let's get this out of the way first. let's get it out the way first. There we go. All right, and then you should see me first. Now this should work. Oh, come on. Shh. Hmm. All right. I'll instead put it in here. Can I then do this? Can I do that then? Oh. Ah. Really? Did I forget to do something? I did! I forgot to remove this restriction. I did. I forgot to remove that restriction. There it is. There it is. What the? There's a mile! And it only happens whenever you first try to convert a kilometer into a mile. This is so stupid. Oh, whoops. Oh, it started to rain over here. Okay, so let me quickly take a picture of this. There it is. What the fuck is a mile? I don't know if anybody's still here to see this, but there it is. We've managed to get what the is a mile. All right, now to actually implement the other thing that I want to do. In here, let's get all the SI prefixes in. Let's see. SI prefixes. Metric prefixes. Oh boy, this is going to be fun trying to having to re-encode all of these. uh, hmm. So you have Quetta, Rona, Yot, Yota, Zeta with two T's, Exa, and then this is Terra, no, Peta, Terra, Giga, Mega, Kilo, Hecto, Deca, and then we no prefix 10 to the 1 to the 0. Deca, Deci, Centi, Milli, Micro, Nano, Pico, Femto, Atto. Hang on, let's see. Deci, Centi, Milli, Micro, Nano, Pico, Femto, Atto, Zepto, Yocto, Ronto, Quecto, and that's all the that's all the SI prefixes, at least the ones in Wikipedia. So now to derive a bunch of quick conversions for these. Let's just hard code them here. Private. Nice. So now we just have to do... I have to name all of these, which is annoying. Wait, hang on. I need that tab back because I need all the shorthands of the prefixes. Oh my god, that's way too many. So you have Q, R, Y, Z, E, P, T, G, M, big M, K, H, D, A. And we have no prefix. We have D, C, M. Can I use Unicode? I don't remember. Let me just quickly steal this mu symbol. Yeah, I can. And... oh, come on, really? Non-ASCII... Fine. Fine, ruin my fun, will ya? P, F, A, Z, Y, R, Q. And I don't need that one. Oh, whoops. That was close. One moment. Now that was close. Right. Wait, am I missing some? Deci, centi, milli, micro, nano. I'm missing pico. I'm still missing something. Pico? I put pico in the wrong place. Pico, femto, atto, zepto. I'm missing yocto, which is after zepto. Okay, and now I just have to fix all of the types. Oh, I know how to make this single letter. U. There we go. And there we go. That's all the SI units. Sorry, the SI prefixes. Hmm. There is another set of prefixes that I now need to realize. The 1024 prefixes. Be right back. I need to quickly do something. Alright, let's go back to some really dumb implementation. There is another set of prefixes that I now just realized. Um, what are those prefixes called, actually? So these are called... Shut up. I don't care about your cookies website. So what is it called? Storage... No, what's it called? Binary prefix, that's what it's called. Now let's also do object. Um, Import IEC. And there we go. And I just realized this is gonna be 1, 2, 3, 4, 5, 6, 7, 8. Nice. And there we go. Now we got a bunch of prefixes. Whoa, careful. I almost knocked everything over again. Okay, now that we've gotten all of this, let's try some conversions. Alright, now that we've gotten all of this, let's try some conversions. Let's do some conversions now. Hmm. And there we go. Oh, wait, no. Let's see what the... Oh, yep, there we go. Nice. If anybody's here, can I have a relatively complicated conversion? Like, that's actually used in real life. I guess no one's here, so I guess I'll have to find one. I guess I'll have to find a complicated conversion. Fine by me. Let's encode... Oh, hang on a minute. Let me actually also do one more thing. Is division left or right associative? Division is left associative. Okay, so we actually want that. Okay, so I can make multiplication right associative. Good. Hmm. Let's see. Meter, mile, uh, okay, let's see. Here's a bit of a test. Let's actually give this a real let's actually give this a let's give this a real value, right? Uh, right, what was the value again? It was something like what was the value again? It was like 1.61. Oh god. Uh 1 kilometer in miles. Nope, 1 mile in km. That's not what I mean. 160934. Let's actually flip this over then. Yeah. Hour to second. Let's actually do hour. Yeah, hour to second. So let's try this call. Let's try a complicated conversion. Let's convert. Let's convert kilometers meters per second into miles per hour per second. Looks like I can't derive it. Where does it get stuck at? Oh, you can't find it. Hmm. You can't find meter to mile, which is a little concerning. Hmm. Let's take a look. So what's missing? What the... I guess it can't figure this out is the problem. I have to figure out... I have to convert negatives. This is what I was afraid of. Compound units. Oh, bother. Oh no, compound units. This is what I was afraid of. uh. Hmm. Wait, hang on. That's I can do simplification steps really easily. Can't I? Let's see. Can I expand this? Hmm. Hmm. Oh, I just realized the units don't make any sense. I just realized the units don't make any dimensional sense. Whoops. Oh boy, I just realized there's a lot more expansion rules that I'm gonna need as well. Oh no. There are so many of these that I need to write. Oh god. Hmm. Actually, I can probably get rid of this, now that I think about it. I can get rid of the B. I just need A to the N, and then I just need A to the... These are getting far more cursed than what I signed up for at the beginning, but that's the risk of this kind of thing. What am I doing? Oh, hang on. This is just big decimal 1. I don't need a conversion constant. Hello. Hang on a minute. A to the power of N becomes that on the right-hand side. Then we have A to the power of N becomes on the right-hand side this. This con doesn't make any sense. Yeah, sure. This should expand second squared into second times second. Or not, I guess. Let's see. Candidate. Oh, bother. It does look like I need, It looks like I do need to do some expansion of... That thing I said a long time ago where I said, would I ever need to do something like this? Would I ever need to do something like that? I thought I was going to I was going to be able to avoid it, but it looks like it's inevitable. So let's encode it. So let's encode it. So let's expand it. Fun. I don't have multiplication. I've just realized. No, I need to define multiplication. No. I have to define a multiplication. Right, so before I do any of that then... Okay, so before I do any of that, what happens if I, cheese it a bit by doing this? No? It still can't figure it out? Mm. Mm. Surely... Meters to mile. Really? It can't find using invert. Really? Oh. Oh. Really? Really? It can't find it from there? Beta, Iona, Iota, Exa, Exa. I mean, I guess I have to do... Oh, God. Hmm. How do I do this, then? Oh, I know. Hmm. Is not a subtype of. Well, we're gonna need to do some more funny things with this then. Okay. You can't chain prefixes, so let's get rid of these. Where does it get to now? Okay, it's found that. So this should be from a transitive conversion. Probably from... Invert conversion. Mile to meter. Integrated conversion. Well, we have this. And now we need kilometer to meter, which surely comes from invert conversion. Not found, conv. Really? Diverged? Oh, really? It diverges? Does it? Oh, God. This is going to be painful. What the hell is XML start? Wait, what? Hang on. That doesn't look right. Hang on. XML start. Identifier expected, but XML start found. That doesn't seem right. Oh, crap. Is this thing still working? Yeah, sure is. Alright, fine. You won't let me use this as an identifier. I'll use that. Diverging implicit expansion from meter to mile. Oh god, this is pain. Where does it diverge? Not found. So it's here. Candidate. Should be from here, right? Wait, seriously? Really? It diverges here? It diverges here. That's interesting. There's multiple. Oh, no. Um, we have a situation. Um, we have a problem. We have a problem. It diverges. That's not good. Do I really have to put identity conversion lower in the priority list? Okay, let's try that. This is the annoying part of using Scala 2 and not Scala 3. I have to constantly baby the process of like, oh, you don't like it when I put that here. Well, time to redo everything. That's not the right button. What the hell did I do? Let's make this stage 4. Seal trait conversion stage 3. And then we move identity conversion. Let's move identity conversion not there. Let's move identity conversion all the way to stage 4. Oh, I hate this is the part that gets annoying. I have to constantly baby this process. Because if there is a bit where it's like, oh, I can't tell whether it's this one or this one that I should use, it starts complaining. So I have to baby the process. All right, what do you say now? Really, it diverges here? Really? How is that not found? Surely it finds K. Really? Oh, am I... Oh no, did I use the wrong one? No. No. Oh god, I used the wrong one. I used the wrong one. I am a little bit dumb. Just a tiny bit. Oh god. That's not the right button. And there we go. I accidentally flipped one of the conditions. Am I... This is, great. Please don't diverge. Great. We have a diverging implicit. It's not ambiguous, which means it can't... It diverges, which means it can't find it. Why does it diverge? That's odd. Why does it diverge? Hmm. That works, so why does this not work? Hmm. Wait, huh? There's an applicable candidate here. Yeah, this is the hard part. I have to now move a bunch of stuff. Where did I put... Oh, where... Oh god, what the... What? Um... Okay, my editor was just having a minor stroke there. Where did I put transitive conversions in this? Next to identity, what? Do I have to put transitive conversions all the way at the bottom of the stack? Now we take conversion stage, this all the way to here. Put that at the very bottom of the stack. Maybe that will stop it from doing... I don't know. Let's do a simpler example then. Just to avoid crowding the thing. Let's convert meters to miles. 1,000, I don't know, 20 meters per... 20 meters... 1,600 meters to miles. Can it find that? Hmm. Why does it keep going around in circles? Where does anything go here? Where does anything go in here? That's a good question. Where does anything go? Oh no, what have I done? Huh? Now I can't figure this out. What? Where did I put invert? Here? Where do I put it? I'm so confused. Sorry about that. Something just broke off again. That's like the second time that mic has fallen over. God damn it! All right, let's see. What was I doing? All right, yeah, I wanted to move you. Oh God, this is so messed up. This was the issue that I encountered um a while ago. Diverging implicits, because I don't think this thing can. Unlike the Scala 3 has much better resolution than this, like resolution capabilities than this, but here it's kind of doing its yeah. See, it just keeps trying. In some cases, invert is better. In some cases, transitive is better, but they seem to conflict with each other. Hmm. Oops. Huh. I am confusion. I am very much confusion. What do I do? I guess there is one design thing that I haven't actually considered. What if I made the conversions two-way from the very beginning? Possibly. I don't know. And I'm this close to giving up. But let's see. Can we get this working? Alright, let me try something really stupid. Because let me see if I can do something extremely stupid. What if we get rid of invert conversion entirely? So we take invert conversion. Where is it? So see this? Just chuck it out the window. Just throw invert conversion out the window, right? Screw invert conversion. We don't need you. Let's instead take convert from, turn it into another version of convert to, where we instead do conversion.invert.constant. There we go. Where we instead do invert conversion dot constant. Let's see. In, out. Yeah, okay. Oh wait, hang on. That's already got it right. I don't even have to invert. I can just do that. What if we just completely throw inversions out the window? What happens? Uh, Awkward. That is one thing I actually never noticed. I have this, and I already defined it like this. Why didn't... Why do I even need invert conversion? I don't need invert conversion. Dang it! uh, I don't need no stinking never mind, I do actually need invert conversion. Awkward. Unless... Awkward. We don't have one of these. Well, this has to end up being convert from. No? I mean, I guess I did define it in a weird way. I defined it like this. This is... Ideally, this is going to be out to in. All right. It's also going to be a times. Yeah, this is converting from meters to kilometers. What do I convert to, right? Which is so strange that it just won't let me. Hmm. 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 I have a stupid idea. I have a really stupid idea. What if we just make the conversions all two-way? This is a terrible idea. This means we don't need this crap. This means we don't need that. Screw that. How about we do something stupid where instead of returning... What if we make all the conversions two-way, where we do this, remove this weird invert, We don't need you. Screw you. We don't need you. What if we do this as... what? Can you not inherit a trait multiple times? Is that seriously not a thing you can do? Ah. That's not a thing you can do? Aw. Oh, right, yeah, because that creates the diamond problem. Fun. Right. Because that leads to the weird problem with inheritance. So it means the idea, I think we'll just have to deprecate this. Throw this out the window, right? What if we just throw that out the window, right? Just make the conversions two-way, right? Ow. This probably still breaks. Yeah. For now, it still breaks. But... is there a union type in Scala too? Let's see. Type disjunction. Either arbitrary arity union type. Hold on a second. Wait, no, that just introduces the problem again. Dang it. That just introduces the problem. Hmm. 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 This isn't helping very much, is it? This isn't helping very much, is it? Hmm. I've got it. No, it doesn't. Never mind. Okay. I think I might have to consider working on this later. I don't think this is working the way I want to. Bit of a shame. Because I encountered the same problem that I remember now when I was trying to implement it like a month and a bit ago. The implicits just start getting in the way of each other. I might try re-implementing this in Scala 3 at some point and seeing what happens. Maybe it'll do better. Who knows? Well, that's a bit of a shame. Don't think there's anyone here, so at the moment, so I'll just stop it here. Thanks everyone for being here. Sorry, this didn't quite end up very well, but that's such as the nature of these weird experimental thingies. Oh well.